Hello and good day, Algebra. We are starting Unit 4 in Trimester 2, and this is going to be continuing with our studies of graphs. Last unit focused on things like slope, and linear functions, and writing equations, and things like that. We're in the same realm here, but we're going to be looking at a few different forms, different things, characteristics, things like that. And we're going to start with talking about what's called direct variation. Any idea what direct variation is in the mathematical sense? You've heard that term before, used it before, an example of it. Or are we all learning something new today? These are my favorite days. We all learn something new.
Oh,
Yes, Lisa.
I know what variation is.
What does variation mean?
It's like a bunch of different kinds of something or lots of I'd say
Really, morning for you. You alright? So different kinds of something you were saying, yeah?
So you say you have a bunch of cookies and then there's chocolate chip.
Okay. Yeah, and kind of bridging from
variation
from that. We're going to talk about variation in terms of change. Okay, change. And where do we use that word change very recently? What were we kind of talking about, Ellen?
Oh, change in y over change in x.
Okay, so we use a change in y over change in x to talk about slope, right? And so direct variation, you can kind of think about that is a direct change or a direct relationship. And what we're talking about here is a direct relationship between the slope and the y-intercept, such that direct variation is a linear function. And basically, what's a linear function? What does it look like on the corner plane?
It's a straight line.
It's a line, okay? A linear function with a y-intercept of 0, okay? A y-intercept of 0. We're starting at the origin when we start to move across the corner plane. And when I say start, I mean we're talking about lines, so there really isn't a start and an end here, but kind of typically when you use this, you'll be looking at a specific set of data, okay, and that's usually going to start at the origin. So determining direct variation, basically we need to decide whether it's a graph or an equation or a table, is the y-intercept 0? Okay, is the y-intercept 0? If it is, direct variation exists. Okay, is the y-intercept 0? If it is, then direct variation exists. That's basically it. Okay, so we're still working with slope intercept form. We're still working with writing equations, but now we are looking for those relations, those types of equations where that y-intercept equals 0. Okay, the first one that you're given is graph. Does that pass through the origin?
Yes.
Is the y-intercept 0?
Yes.
Does direct variation exist?
Yes.
Yes. Okay. What does it say here? Write the relation y equals mx plus b to determine if the relation is a direct variation. If it is, find the constant of variation. The constant of variation is just a really fancy phrase for slope. Right? Because direct variation is like that direct change, and the constant of variation would be that constant change. Constant change is slope, right? It's the same thing over and over again. So yes, direct variation exists. What's the constant of variation, or what's the slope here, Aiden?
1/3.
1/3. Right? From this point, or from any point, we're going up 1/3. Change in y over change in x. Okay, you got this. This is all good. Y equals 4x plus 2. What's the y-intercept of that equation? Max?
2.
Is it direct variation, Max?
No,
Why not, Max?
because y-intercept is 0.
Good job, Zach. I almost called you Zach. Max.
Yeah,
I'm
Zach.
saying Max like 8 times. No, direct variation does not exist because it's got a y-intercept of 2 and not 0. Okay. Let's look at the next one. We've got a table here. This one's going to probably be the most work of all of them because we need to actually write the equation in slope intercept form. So this goes back to CO24, where you have to kind of determine what the slope is use that to solve for the y-intercept. You just did this on your most recent test, which you get back soon, by the way. Okay. So for starters, is this linear?
Yes.
How do you know?
But it's not.
How do you know it's not? Jack?
Because there isn't a repeated thinking about her.
Oh,
Hmm.
I get it.
Okay, let's expand on that. Chris Birch? Lisa?
I remember. There's a pattern in the y-intercept, and then there's in that x line thing. There's no repeated letters or numbers.
So you're talking about if it's a function in general, but remember for a linear function, we're looking for that change in y over change in x, right? Let's just look at what's going on here. From 4 to 12 is plus 8, from 12 to 16 is plus 4, and from 16 to 28 is plus 12. Remember, we can't look at this and automatically say there is no slope, right? Because like we've seen before, it's possible that we're just kind of jumping around the line here. We do have to look at that x change as well. So from 3 to 9 is plus 6. From 9 to 12 is plus 3. And from 12 to 21 is plus 9. Does slope exist here?
Yeah.
It does, right?
What?
Because you need to sit still. Okay? Because what we're looking at is that change in y over change in x. We've got a change in y and change in x of 8 over 6. Then we've got one of 4 over 3. And then we've got one of 12 over 9. What's true about 8 over 6, 4 over 3, and 12 over 9? Damien.
They all can be divided by 3.
They're all equivalent, right?
That's what I'm
The fraction 8, 6, 4 thirds, and 12 ninths, they're all equivalent fractions. So does slope exist? Yes. Okay? So we can start to write our equation here with a slope of 4 thirds. But we still need to figure out what the y-intercept is to determine whether direct variation exists or not. So what do we do next? Think back to CO24. What's our next step? Arlene.
Choose an ordered pair and then plug them in for y and x.
Which one would you like?
This one.
Well, here we've got 4 options. So actually,
These ones are 34.
3 and 4. Okay. So 4 equals 4 thirds times 3 plus b. How Arlene got that, right? Which is picked one of the ordered pairs. Does not matter which ordered pair you choose. Plugged in the 4 for the y in slope intercept form. There's our slope, the 3 and for x and for slope intercept form, and we're solving for b. Okay. Turns out that 4 thirds times 3 equals 4. So we get 4 equals 4 plus b. Get b by itself by subtracting 4 from both sides. And yes, indeed, this is going to be direct variation. Right? So the table is definitely the most work here, right? Because you can't look at the graph and see where it passes through the y-axis. It's not an equation where you can kind of, put it in slope intercept form. You have to write the equation yourself. So tables are the most work, but it's just like PO24. Once you get to this step and realize that the b is 0, yes, it's direct variation. And what is the constant of variation? The slope, right? It's a fancy word for slope. What's the slope, right?
4 thirds.
4 thirds. We already found it. Okay? So that's basically what you're doing today. Right? You're looking at whatever type of relation it is, graph, equation, table. You're determining whether or not direct variation exists. Basically, is the y-intercept 0? Okay? Questions?
Can we go over 2 more?
Maybe not entirely, but yeah, we can talk about it. So, Damien, what are you looking at further down the page and having questions?
Confused on the graphs, on the x and the y axis.
Okay, like which one's which? Which one's x and which one's y?
Well, I know which one's the x, but I don't get how to find the if it's a variation or not.
So what we're looking for on a graph is, does your line pass through the origin? Because if it does, that means the y-intercept, right, where it crosses that vertical axis, is 0. So that's why we said that this first one was yes, it is direct variation because it passes through the origin. The one right below it, does that pass through the origin?
Nope.
No, so it's not direct variation. So you move on with your life. Okay?
Sick.
Yeah. Claire.
I'm confused. Did you just like on the second one or the third one on the top of the graph?
Mhm.
Did you just pick 4/3 or is it like?
To find the slope?
Yeah. Did you just like pick to choose like?
No, we found that the change in y over change in x, right? This was 6, this was 3, this was 9. And we looked at the 3 fractions that we created here, that change in y over change in x. We had 8/6 for the first set, right? Then we had 4/3 for the second set. And we had 12/9 for the third set. Because all those fractions are all equivalent, right? Then we knew that slope existed, and that's where the 4/3 came from. We always want to take the one that's in simple form. It's kind of a mathy thing to do. It's kind of fun. Great.
Say like the table isn't like a linear function.
If it's not a linear function, it cannot have direct variation.
So you just move on.
You just move on. Yep. In order to have direct variation, it must be linear, and it must have a y-intercept of 0. Yeah.
Can we go over last one in the second row?
The table? What's your question on that?
Okay.
Well, where would you start?
I just don't understand with like how it's going like down and up. And
Okay, so what's the change from 14 to 35?
21.
21. All right. Put positive 21 here. What's the change from 35 to negative 7?
Negative 42.
Negative 42. Okay. And what's the change from negative 7 to negative 70?
63 negative.
Negative 63. All right. So we can't make a determination yet. We have to compare to what we get for the change in x. So what's the change in x from 6 to 15?
9.
9. Positive 9, right? Okay. How about from 15 to negative 3?
Negative 12.
Negative
No, that's
18.
Oh.
And then negative 3 to negative 30?
Negative 27.
Negative 27. Now what you have to look for here, these 3 fractions, that change in y over change in x, does 21 over 9 equal negative 42 over negative 18
Wait, no.
equal negative 63 over negative 27.
Yes.
How so? They look very different to me.
Because 21 can go into 42 and it just go into 63.
You can't go into negative 40.
Oh yeah.
So, Jack, you're right?
Yeah.
21 can go into 42, can go into 63, kind of ignoring the signs for now. 9 can go into 18, can go into 27. But those negative signs, we can't just ignore them completely. We're on the right track.
Exactly.
But what does 21/9 simplify to be, Claire?
Oh,
Okay, go ahead. Okay, a negative divided by a negative is a positive. So 21/9, which simplifies to be positive 7/3. What will negative 42 over negative 18 simplify to be?
7/3.
Positive 7/3. And what will negative 63 over negative 27 simplify to be?
7/3.
Spoiler alert, positive 7/3. Right? So you really need to not just use the eye test, but actually mathematically conclude. So yes, this at least has a slope. We don't know if it's a direct variation yet because we have to then plug it back in to find the y-intercept, but it does have slope. We at least have to explore. Sophie.
Can we go over?
So you can finish this one. This one's not done yet. Okay. We have about 45 seconds to go over the bottom section here. Basically, you need to put these equations into slope-intercept form.
What?
Okay. Which recall, well, this is standard form. You did that in unit 3. This is standard form. Kind of. Not at all, actually. But just get y by itself there.
This is what
You can work. The only one you might have trouble with is this second one, and the first one that you should do. First thing you should do here
No.
I felt so smart for doing that, right?
is distribute, and then get y by itself. Right? All 4 of these equations, basically, you want to get y by itself, folks, and then see if that b value's 0. Andrew.
Me and Alex have to go serve in church.
Excellent. You may go. Anyone else that needs to go do massy things? You can go do your. All right. This will be homework for tomorrow. Okay. Do what you can on it, and we will talk about it then. That's my math, folks.